Okay, so our topic, tangent ratio, is our topic. Turns out this ratio you've studied before. It wasn't called tangent ratio, but it was something else. Maybe you'll figure this out later. Okay, as we learn this, and maybe some of you will figure out, oh, that's what we learned. So let's start with this. Who would like to read for us? So this is sort of a starting of trigonometry, kind of. So who wants to read this for us? How about, let me call somebody at random. How about, give me a sec. David.
The word trigonometry comes from the Greek words that mean triangle measurement. In this book, our study will be limited to the trigonometry of right triangles. In the right triangle shown, one acute angle is marked. The leg opposite the angle and the leg adjacent to this angle are labeled. The following ratio of the lengths of the legs is called the tangent ratio.
Thank you. So there is a tangent ratio. Okay, so if you have a right triangle, as is stated before, we're going to be talking about right triangles only. In this right triangle, the ratio of the opposite leg right here over the adjacent leg is called tangent ratio. That's all. So it's got some name. By the way, take a look at this triangle. Why do you think this side over here is the opposite leg of the angle A? Anybody have any guess? Why is this the opposite? How about Nico? What do you think?
Because it's opposite the angle A.
Yeah, it's the opposite side of the angle A, right? But then what about the adjacent leg? Why is this one the adjacent leg? Why can't the one on the above be the adjacent leg? Anybody have any idea? Joshua? Isn't this also adjacent? Adjacent means next to this angle, so angle A. Why can't this be the adjacent angle? Why does it have to be this one? It's a bit, kind of. What do you call this, Joshua? That's the hypotenuse. So we don't call hypotenuse adjacent or the adjacent or opposite leg. Okay. So hypotenuse is hypotenuse. So we exclude hypotenuse, right, in right triangle. So when we're naming these, so that's why this is the opposite leg and adjacent leg is the only one that's left. Does that make sense? An opposite leg is easy to find. It's the side, right, opposite of that angle. Is that okay? So take a look at the triangle right below here. We got triangle XYZ. Okay, who can tell me then the tangent of x? By the way, in order to abbreviate, we don't have to write the whole tangent. They will do it this way, tan A. But you don't read it as tan. It's tangent. Tangent of A is opposite of adjacent. So take a look at this triangle. Can somebody give me the tangent of x? How about Jonathan? So let's look at the angle x. Which side is opposite of this angle x? Say it again. ZY is correct. So ZY is the opposite side of this angle, isn't that right? Then which one is the side is the adjacent leg? You have two choices. Is it XZ or is it XY? Take a guess. 50-50 chance. XZ is correct. Why not XY, Jonathan?
It's not the adjacent side, or the leg adjacent to X.
Well, yeah, it is. This is adjacent to X. This is also adjacent to X. But what about XY? What is XY really called? It's opposite of the 90. It's the hypotenuse. Remember, we don't, right, include the hypotenuse. So it's got to be, yeah, it's got to be ZX. Right? Does that make sense? So then what is the tangent of XY then? It's the ratio of these, the length of these sides. So how about Josephine, what do you think? What is the tangent of this X going to be then? 12 over 5. It's 12 over 5. Easy? You see how we could figure this out pretty easily? Yes? Now, this 12 was the opposite of X, right? Now, if I'm talking about angle Y, would that side 12 be opposite angle again? No, it changes, doesn't it? Depending on which angle you're talking about, right, the opposite side changes. Okay, so what about for angle B? Brandon, what do you think the tangent of angle B then will be?
Angle Y.
I'm sorry, angle Y. Yeah, we just did X. Sorry. Angle Y.
5 over 12.
5 over 12. How many people agree with Brandon? Raise your hand. Anybody have a different answer? It is 5 over 12. Okay. Because, right, we're talking about the opposite side, which is the opposite side of this angle y is 5, and the adjacent side is 12. It can't be 13 because 13 is the hypotenuse, right? Right. Is it possible to find tangent of z? That's a great question. Josephine is asking. Do you think we could find the tangent of, yeah?
No.
No, why do you think so?
Because the hypotenuse is not a leg.
Hypotenuse is not a leg, exactly right. So, yeah, it turns out you cannot find the tangent of like 90 degrees. Turns out it's sort of undefined. Okay, good question. Okay, because you don't have, right, opposite, or, you know, it doesn't really have an opposite. You can't call that an opposite side because, you know, that's the hypotenuse. Yes?
Does it only work for right?
Yes, these are only work for right triangles. So these ratios are only for right triangles. Yeah, exactly. So you can't just give me any triangle, right, and say,
Like the adjacent.
right, you have to have a hypotenuse, right? And then not every triangle has a hypotenuse, right? Okay, any other question? Yes.
So what do we use the tangent for?
We'll find that out. Yeah, we'll learn. Very good question. Well, so why do we need this tangent ratio for, right? That's exactly what we're getting to. Why do we even need to, what's the significance? Okay, so that's a good question. So Josh, why don't you, actually, hold on. Let me move this up. So Josh, why don't you read this for us right here? It says inner right triangle.
If the right triangles shown below, measure angle A equals measure angle R.
Mhm.
By the angle similarity postulate, the triangles are similar. We can write these proportions.
Okay, so let's think about the proportion that we could write. So, but before we move on, do you all agree that these two triangles are similar? Well, they only told us angle A is congruent to angle R. Why is it angle? Because there's only one angle, pair of angle that's congruent. Jason? Okay, they both have right angles. C and T are right angles, right? They're both right angles. Therefore, by angle, the two triangles are similar, right, Josh and Jason? Okay, so then if this is true, what sort of ratios? What do you know about similar triangles? What do you know about the corresponding size of similar triangle, particularly? Jocelyn? Yeah. So side A, A to R is equal to what? B over S. Would you not agree? Right? Those are corresponding parts of similar triangles. They're in proportion. If that's true, let's use the property of proportion to rewrite this as A over B is equal to what? Using property of proportion. R over S. Would you not agree? And what do we say? What do we know about the ratio of the A over B? What is that called? Tangent of?
Tangent of ratio.
No, tangent of which angle? Jordan? A over B is tangent of which angle?
R over S.
Right, so A over B is tangent of which angle in this triangle on the left? Which angle is this tangent of? A over B. Angle A. Good. What about R over S, class? What is this R over S tangent of? Which angle? How about Narek? What is R over S equal to? So we know that R over S is the same as tangent of which angle? So A over B was tangent of angle A, wasn't it? Because A is the opposite side of this triangle. Angle R is correct. So this is what we got, right? From definition of tangent ratio, right? We know that tangent of A is equal to tangent of R. Correct? In these two similar triangles. Turns out this is very significant. Why? Why is this important? And Josh was asking, why are we learning this tangent ratio? What's the point? Go ahead, everybody. I want you to discuss with your group. Why do you think this is important? To understand that tangent of R, A is equal to tangent of R. Go ahead, everybody think about this. So anybody have any guesses to why this is important? How about Kaylee? Did you guys come up with anything, your group? It helps to prove that triangles, okay, kind of. It helps to prove triangles similar. Okay, that's good. Also, anything else? Yes. Hannah, what did you guys come up with?
Tangents of corresponding angles of
They're equal. Tangents of corresponding angles of similar triangle, well, except for the angle that's 90, are equal to each other. That's right. It doesn't matter how big the triangle is or the other triangle, how big it is. As long as the two triangles are similar, right? The two angles within the 90, the tangent will be same. That's important. Why? Yes. You have a question?
Yeah.
Yeah. What is it?
Can you like use the tangent to like find if the triangle is a right triangle?
Well, tangent is given that you have a right triangle to start with.
Yeah, but if it. Oh yeah.
You know what I mean?
So the
But you could actually later use that to figure out something about regular triangle. But that's later. So what we got here is, it doesn't matter, as long as two triangles are similar, the tangent ratio would be same.
so the tangent ratio angle A is equal to the tangent ratio of angle R.
Yes. That's what it says right here. Tangent of A is equal to tangent of R. As long as what? The two triangles are similar. Does that make sense? So this is sort of nice because knowing this, somebody read this for us. They kind of summarize this for us. This is important because knowing this, we could actually do some example that involves tangent. Katie, can you read this for us?
We have shown that if the measured angle A equals the measured angle R, then tangent A equals tangent of R. Thus, we have shown that the value of the tangent of an angle depends only on the size of the angle, not on the size of the right triangle. It is also true that if tangent A equals tangent R for acute angles A and R, then measured angle A equals measured angle.
So it doesn't, look what it says here. It does not, what does it say? Tangent of angle depends only on the size of the angle, not the size of the triangle. Okay? So if you know tangent ratio for 30 degrees for one triangle, guess what? It's always going to be true for every similar triangle. In other words, any 30, 60, 90 degree triangle, the tangent is always the same. So you just have to find one. So watch this. Let's take a look at. So let's look at the very beginning. We talked about the ratios. Nice review. 30, 60, 30, 90. What do you know about, well actually I should have drawn the other way. Right? This should be 30, 60. What do you guys know about the ratios of this right triangle, 30, 60, 90? The side opposite of 30 degrees is 1, 2. What's this one? This is rad 3, 2, 2. You guys remember that? It's kind of like 1, 2, 3, except rad 3 is square root. Because that's got to be the smaller side, remember? Remember, the hypotenuse of this was twice of the shortest leg? Right? That was the ratio, right? I could actually do 1x to 2x to 3x if you want. Right? Does that make sense? So what is then going to be tangent of this 30 degrees angle? Well, it's going to be the opposite side, which is what? X over the adjacent side. Can it be 2x? No, 2x is the hypotenuse. It's over what? Rad 3x, which is equal to? Well, x is cancelled out. 1 over rad 3, and we can't leave it that way. It's rad 3 over 3. So it turns out, you give me any 30, 60, 90 degree triangle, no matter how small or how big it is, the ratio, the tangent ratio, which is the opposite side over the adjacent side, the ratio is always going to be rad 3 over 3. You give me any 30, 60, 90, it's always going to be the same. Pretty cool, huh? It is always true. And knowing this fact, actually they could do something else with it. Just wait, we'll do someone once, but this is nice. Okay, if we could do that, we could also find the tangent of 60 degrees. Can we not? What would the tangent of any 30, 60, 90 degree triangle where it is 60 degrees, right? Tangent of 60 is always going to be what? What's the opposite side of the 60 degrees? Rad 3x over 1x, which is simply rad 3. There you go. This is always going to be true. You give me any 60 degrees, right, in a right triangle, the tangent of that triangle, the 60 degrees, is always going to be rad 3. Is that nice? We could do a similar thing for, we also know another triangle, right? What? 45, 45. 90. So here's red x to what? Red
Red
2x, right? So what is going to be the tangent of 45 degrees?
X over
X over x. What's x over x, guys? Okay. Turns out, if you have tangent of 45 degrees, it's always going to be 1. You give me any right triangle with 45, 45, 90, right? Tangent of 45 degrees, no matter how big or small it is, it's going to be the ratio of the opposite side of adjacent is always going to be 1. Okay? Is that okay? So these are nice because we could use this sort of ratio for triangles that we know, right? Of right triangles and so forth. They actually did all this for triangles with 1 degrees, 90 degrees, and 89 degrees. And they actually measured these because they constructed a triangle with 1 degree. Okay, opposite side will be really tiny, right? 1 degrees, 1 degrees, 90 degrees, and 89 degrees triangle.
Because 1 plus 89 is. Oh wait, no, that's percent.
And they did one for 2 degrees, 90 degrees, and what? 88 degrees. They did for 3 degrees, 9 degrees, and so forth. They did all this, and they made a table for us. So here's a table, kind of nice.
The periodic table.
It's not a periodic table, but here. So notice it says table of tangent ratio, trigonometric ratios. The tangent is the one on the 3rd column. Don't worry about the sine and cosine. We'll learn those tomorrow. Those are again another ratio. Okay, but let's verify. Look at this. We said tangent of 30 degrees. Okay, let's look at tangent of 45 first. Okay, what did we say tangent of 45 degree was? It was what? 1. So let's go to tangent of 45. I think it's way down here. Oh, it doesn't say 1. It says 0.7071. Oh, that's the sign. Oh, which column do we want? Okay, so tangent of 45 is going to be 1 right there. Okay, turns out what is actually exactly 1. Turns out the other ratios, as you can see, for 44 degrees it's 96.57. I mean 0.9657. So these are all approximations. Is that okay? Does that make sense? But for 45 degrees it's exactly 1. Anyway, let's go to tangent of 30 degrees. Can somebody punch this in your calculator and round it to nearest 10,000s? Because that's what they go up to, 4th digit here. So what is rad 3 over 3? What does it come out? Let's see if it got it right. If you have a calculator, can you guys punch it in? Let's see if this table is correct. Rad 3 over 3. What does it come out to? Raise your hand if you have it. Yes, sir. What did you get? Shh. Okay, so let's round to nearest 10,000s place. Point, what? 35. So it's 0.5774 to nearest 10,000 place. Would you not agree? Let's see if that's what they have. Tangent of 30 degrees. There you go. 0.5774. Pretty cool, right? Let's look at the tangent of 60 degrees. Can somebody punch this in the calculator? Rad 3. What do you get for rad 3? Someone else? No one else? Leo, what'd you get?
1.7.
1.7 what? 1.7320? Oh, 5, so it's 1.73. You will round, because I want to go to nearest 10,000 place. So 1.732 about, right? It's not exact, right?
Yeah.
So let's see. Let's go to 60 degrees. There you go, 1.723, right? So this table, not only do they have the ones like 30, 60, they have one for 1 degrees. It's about 0.0175. They did it for you. So you got a bunch of tables that has all the tangent ratios of degrees from 1 through 89. Why do you think they don't have, how come they don't have 90? Yeah, it's undefined, okay? Because you don't have an opposite, right? The opposite angle of 90 degrees is hypotenuse, okay? So you can't have one. Right, so, therefore, it actually becomes, as you can see the trend, look at the tangent. It actually increases, doesn't it? It actually goes to infinity if you put 90. Anyway, so, that's what we just have here. Tangent of 30, 60, 45, and then it has a table. And so what are we going to do with this table, and what kind of problems are we going to have? Well, let's do an example 1. So everybody get out your notes. Let's do example 1 now. So example 1 says this. Find the value of y to the nearest tens. whenever you do your homework tonight, because this table is an approximation, these values, right? I want you to give me the exact answer and an approximate answer, just like before when you had square roots and so forth, right? So I'll show you how to do it. Okay, so how do you find the value of y? Well, by the way, could we just use a Pythagorean theorem on this? You have a right triangle. You could? How? What would you do, Jack?
32 squared plus y squared
Okay, there's your problem.
equals x.
Yeah, we don't know. In order to use a Pythagorean theorem, what do you have to know? You need not just the leg. You need, yeah, two sides, right? It could be the hypotenuse and one of the leg, or two legs, whatever. You need two, right? You need two length of the two sides, but you only have one, right? In this case, we could use, and Josh, and this is sort of answering your question, why do we need the ratio, tangent ratio? Well, we could use tangent ratio to figure out what y is. So Josh, what would you do?
Value of y to the nearest term. Maybe y over 32 equals something.
What would that be equal to? We just learned this. One person see it? What would y over 32 be equal to? Because we need to know what that is. Kenneth? What is our topic today? Do you think we could use tangent ratio in this problem? How? It's equal to what? Yeah, tangent of 56 degrees is exactly right. Because Josh, turns out we know what tangent of 56 is, don't we? Well, we don't know the exact value, but we know an approximation. How? Where do we get that from? From the chart. Because tangent of 56 degrees is always same.
Where is this chart?
This chart is in your book. It's actually on page, you might want to write it down actually. They tell you what page it is on. It's on page 311. So when you do your homework, they're going to refer to this chart. And make sure you go to the third column. Okay, first two are the different ratios. Tangent ratio is on the third column. So we could find what y is. Okay. So to get an exact answer, all you have to do is what? Multiply both sides by 32. And you get y is equal to 32 times tangent of 56, whatever that number is. And do we know what that number is? Yeah, let's look at the chart. Let's look at 32 degrees right here. You see 32 degrees? Which one of these are the tangent ratio for 32 degrees?
The third one.
The third one. 60.
56 degrees.
Oh, was it 56? Oh, was it 56?
Yeah.
Okay, let's go to 56. Where is that? 56. Oh, nice. Whoa. 56. Oh, right here. So we need to use this value. My bad. So we need 1.4826. Correct? So, yeah, 32 times 1.4826. It's not 32 degrees, is it? 56. So, by the way, there's your answer. Of course, you all know how to multiply. And at this point, if you wanted to use your calculator to multiply, that's fine. But on the test, you don't get to use a calculator. So make sure you know how to multiply decimals. Anyway, yes. No, you don't. These are already rounded value. The tangent of 56 on the table, as you can see on your calculator. If you punch this on your calculator, actually your calculator has this table in there already. Yeah, and it has a lot better accuracy than to the nearest 10,000th place.
Wait, so we should do one on the table, the number from the table, and then round it to the nearest 10.
Yes. So that's a good question. Yes.
On the test, how would we know?
Yeah, on the test, how would you know these values? I'm going to give you the table. So I'm not going to ask you to memorize the table. That's. Yeah, it'll be like the one in the back of the book. Yeah. Nico?
Do we have to give both answers?
Okay, good question. So Nico says, do we have to give both answers? The answer is yes. Which two answers do I want? I want exact. Which one of these are the exact answer? Yeah. And you can kind of tell. Look, it says y is equal to 32 times 56, right? At this point, we haven't plug in the approximation of the tangent of 56 here, right? So that's why it's equal to. Now look what happens as soon as you punch in the approximation. It becomes a squiggly line, right? That means it's an approximation. So I want this, whoops, I want you to circle this answer right here on your homework when you're doing your homework. I want this answer, y equals to 32 times tangent of 56 in parentheses, right? You need parentheses of around tangent of 56 because that's some number, isn't it? And so I want you to circle that. That's your exact answer. And what's your approximate? Well, you punch into your calculator. You get 47.4 because they say to round to nearest tenth. They have to tell you where to round to. Otherwise, what do you write? Right? So they have to tell you that. Okay, so they will tell you what to round to. By the way, like I said, tangent of 56 is in your calculator. It gives you a lot better approximation. So let me clear this for you. By the way, I know, don't you get this on your calculator normally? How did I get all the other ones? Well, you go to View, click Scientific, then you get all the other buttons. So, I'm sorry? Yeah, they have 10 on it right here. Some of your calculators, not the simple ones, but the scientific calculators have tangent button, don't they? Yeah. So have you ever wondered what that tan means or sin and cos? Yeah, those are the tangent ratios. Yeah, so we'll learn those later. But okay, hold on. Yeah, so you don't need to buy any calculators, guys. You don't need to buy any. I'm just showing you how to. Okay, guys, I'm not requiring you to buy any calculators. As a matter of fact, I don't want you to buy those. Okay, just take a look at it. So look at the tangent of 56. So to get there, you punch in 56 like this, and then you see if you click View to Scientific, you get this function. There's 10 and 10h. Don't do 10h, tangent. You just want to do tangent. That's something else. Don't worry about it. Okay, so you click tangent. There you go. It gives you a nice. It actually has a better approximation than the table, doesn't it? The table. No. The table says 1.4826, right? The calculator goes all the way out here. I don't know how many digits. Okay, so on your homework, should you use the value from the table or should you use the one from the calculator? Okay. How many people say table? Raise your hand. How many people say the calculator? The answer is you want to use the one from the table because that's how they did it. All your answers in the back of the book, they use the table. So if you use this, even though it's more accurate, would it match with your answer in the back of the book? No. So please use the ones from the book, the table. Is that okay?
I really don't want to use that.
So on the test, you don't get to use your calculator, so you don't have to worry about it. Yeah. Yes?
How come it says tan G here while it says tan screen? This is 10H.
Oh, it says 10H. That's something else. That's a different.
No, on the top right.
Oh, right above the number?
Oh, it says 10.
Oh, 10. So they. I don't know.
Like it's past tense.
I guess. Don't worry about it. Okay, so I don't know. All right. Does this make sense, guys? So you want to use the values from the table, but I'm just telling you the ones in the calculator is a lot more accurate. So don't use that because your book the answer won't match. All right. So let's do one more then question. So take a look at example 3. Actually, we're gonna do a couple more, but let's look at our second one. The grade of a road is ratio of its rise to its run, and it's usually given as a slope, isn't it? So guess what? Tangent, isn't that the ratio of opposite of adjacent? Guess what? Tangent ratio is same as slope. It's just another name for it. It's a different name. Right, isn't that right? Isn't tangent, look.
Rise over.
Yeah, rise over run. Isn't that same as opposite over the adjacent of this right triangle? So you've actually learned this ratio before. It's just slope. Yeah. That's what I said. Anyway, so tangent is another way of thinking about slope. Okay, it's the same thing. All right, so take a look at this example. The grade of the road is ratio of its rise to its run, and it's usually given as a decimal or percent. Find the angle that the road makes with the horizontal if its grade is 4%. 4% means what? 4 over 100, which means 0.4, 0.04, right? So this one's a little bit different than the one we did. How come? No, they explain to you what grade is. It's a ratio, it's a tangent basically, a tangent ratio of the slope. So if the tangent ratio is 0.04, this one's the opposite of what we've been doing. The other problems, they gave you the actual angle measure, right? This time, they don't give you the angle measure, but they give you the tangent ratio. So how are you going to find this angle? Well, what do we know about tangent of x degrees?
Well, it equals 4.
Yeah, does it equal to 4?
0.04.
Yeah, it's 0.04. So we know that tangent of x degrees is 0.04.
Should we do 0.04 hundred?
No, you don't have to. But, so how do we do the opposite? How are we going to find which angle gives you the tangent of 0.04? I want you to discuss with your group. Go ahead. How are we going to do this? This is sort of opposite of what we're doing. Any idea? What are we going to do here? This is sort of opposite of what we've been doing, right? What are we going to do? How do you know which angle gives you the tangent of 0.04? How about Leo? Any idea? No? Let me give you a hint, Leo. So take a look at the table. Leo, if I told you that the tangent of some angle is 0.0175, what is that angle?
Oh.
If I told you that tangent of some angle measure was 0.0175, what is that angle? 1 degrees, right? How would you know? Because tangent of 1 degree is always same, right? So if I told you tangent of some angle measure is 0.0875 right here, which angle must give you that tangent ratio?
Oh, I see. I see.
Oh, thank you. You might want to. Sorry. You can, so if I told you, right? I gave you the tangent ratio. I said tangent of some angle measure was 0.0875. It must be 5 degrees, correct? So if we know that the tangent of some angle is 0.04, okay, then which one of these angle must be? Which angle must give you the tangent of 0.04?
The one that has the ratio closest.
Yeah, 2 degrees is the closest one, right?
Where's the
Do you see that?
Yeah.
So guess what? This is going backwards. You have to look backward, right? Don't look at the angle measure. They give you the tangent. Could you figure out what the angle is? Yeah, because what do you know about tangent ratio? It's always going to be same for any similar right triangles with that angle, right? So if they told us that the tangent ratio is 0.04, it must be then the degree must be 2 degrees. We just look at the table and look at backwards, right? Which one is the closest? I mean, it's not exactly 0.04, is it? But it's close. This is one's the closest one. So what do you guys think? Is it going to be bigger than 2 degrees or less than 2 degrees? It's going to be a little bit bigger than 2 degrees. Is there a way to do this on a calculator so you could actually figure out? Because remember, I told you calculator has a better table than this, right? See, this one doesn't give you anything about like 2.5 degrees or 2.2 degrees or something like that, right? So how are we going to do that? Yeah, Brandon? Yeah, there's a way to go reverse, okay? Or it's called inverse. Okay, so let's look at how to do that. Let me show you. So the way to do that is we had tangent of some x degrees was equal to 0.04, right? On your calculator, if you want to go backwards, I mean, on the table it's easy to go backwards. You just read backwards, right? But on a calculator, how do you do that? How do you go? So there's a key called, if you want to get rid of this tangent, let me write this down, tangent x degrees. By the way, if you have x equals to 5y, is there a way to get rid of this? Okay, if this was x, y. Is there a way to get rid of this x? Or this is z. Divide both sides by?
Y.
If you want to get x by itself, you divide both sides by?
Y.
Y, right?
Y.
When you divide both sides by y, isn't that same as y to the negative 1 power? Isn't y to the negative 1 power 1 over y?
Yeah.
So it's kind of similar. So if you want to go back, tangent, to get rid of the tangent, you multiply both sides by? something called tangent to the negative 1 power. And you do the right side, tangent to the negative 1 power. Yeah, on some of your calculators, have you seen some of those buttons? Some calculators have that button. Some calculators, you have to press shift to get to the tangent to the negative 1 power. This is called tangent inverse. Is that okay? Guess what these do? Tangent inverse and tangent A cancel out. Cancel out. Just like if you have y to the negative 1 power times y, don't they cancel out to the 1? Right? Same idea. So you just get x on the left, and you just have to punch in tangent inverse of whatever that number was, 0.4. So that's kind of same as looking backwards on your table. So on my calculator is kind of nice. I think a lot of you have this sort of thing. So you don't see any tangent inverse button, do you? So my shift, or actually I have inverse function. There's IMB, that's inverse. If I click that, look, you see how I get to the negative 1 power? Do you see my tangent to negative 1 power? So I have to punch in that value, 0.04. Oops, that's 0.4. How do you click? Okay, 0.04, yeah? And then I press inverse. And do you see my tangent inverse button here?
Yeah.
I click that. There you go. I get a lot more accuracy. X is about, yeah, it's not really 2, is it? And we expect it to be a little bit bigger than 2, right? It's about 2.3, yeah. It's about 2 point, I'm gonna write 29, yeah, degrees. It's about that, okay? So if you wanted more accuracy, that's what you could do with your calculator. On your homework, they don't ask you to do that, but I want you to know how to do that, okay?
Should we make
So-
2.29 like?
I'm sorry?
Should we write the?
No, so on your homework, they just ask you to use the table. So you would just write down 2 degrees. But if you wanted more accuracy, because your calculator has a better table in it, built in, you could actually figure out what that is. Because this table doesn't give you anything about, right? It only gives you, in terms of whole numbers, in terms of these degrees, they don't give you any, right? Anything more. So you should know how to do this, though. Just know that this is what you do. You multiply both sides by tangent of the negative 1 power. That's how you cancel out the tangent. Yeah, that's going backwards. That's looking backwards on the table, kind of. Yeah. Yeah. So that's a good question. Here's my exact answer. You see on your homework, this is what you do. This is your exact answer. And guess what? This is your approximate. I want both of these. Okay. So exact answer is x equals to tangent inverse of 0.04, and then exact answer is x is about 2.29 degrees. Yes.
If this was on a test, do we have to do the approximate answer?
On the test, yes, because I'll give you a table to look
We
at.
don't know what the we don't know what the tan is.
Oh yeah, you do. On the table, if I only gave you this, you would just write down 2 degrees instead of 2 point. You would just write this.
Oh, okay.
You know what I mean? Yeah, I don't.
Okay.
Yeah, you wouldn't know. What, you know, it'd be a little bit bigger than 2, but you know, so that's what you would write. If I gave you a table, that's what you would write. So this is the exact answer right here. But I still need you to write this.
Okay.
You have to take tangent inverse of both sides, and then the answer is 2 degrees. Yeah, Nico.
What happens if you like type in a calculator 10 and 90?
Right. If you do that, then try it. It will be error. You will get an error because you don't have tangent of 90 degrees. Yeah. So try it. It will just give you an error. Okay. So let's do some other examples now. Some of the simple ones. Okay. Let's do some more examples. Something like this. Okay. So there you go. I have a picture of a right triangle. Of course, I need a right triangle, don't I? If I don't, then you can't do any of these. Tangent. Can you find me tangent of A, angle A, and tangent of angle B? Go ahead. This side is 7. The shorter side is 2. And there's your hypotenuse. Okay. Go ahead and find me the tangent of A and tangent of B. Go ahead. Everybody try. Should be pretty straightforward. This shouldn't take too long. Who can tell me the tangent of A? How about Ethan? 2/7. How many people agree with Ethan? Very good. It's 2/7. I even punched this into a calculator. It's about 0.2857. Why do you think I stopped at nearest 100,000th place? Because that's what table goes up to, right? All right. Next. So that's the. Oh, sorry. I should have put down squiggly line over here, right? Because that's not exact. Actually, you don't have to. So you're right. You could have just stopped. Oops. You could have stopped right here. Yeah, 2/7 is a lot simpler than writing it. But actually, there's part B. So hold on to that. So for part B, you will need that. So anyway, can somebody give me then the tangent of B? Grace, what do you think? Oops. 7/2. And Josh noticed those are always going to be reciprocal of each other. You're right. And I actually, this is an oops. Let me go back. This is an approximation, right? I shouldn't have put equal sign. That's wrong, right? Because those are approximations. All right. So now part B. Guess what? Anybody want to guess what part B is going to ask you to do?
You have to
Find the angle. Yeah, find the angle. So find the angle. Measure of angle A and B. Of course, would this be exactly? No, these are approximate because the tables are approximate. So, do you see why, Jack, I wrote down 0.2857? Because you want to go backwards. So, let's look at the table. Let's look at the, I don't think it's going to give you the exact number as this. Let's try to look for something that is closest to 0.2857, okay? So, oh here, right here. Is it 0.28? Can I use this one? No, that's a sign. No, you don't want to use the sign one, but be careful. You always want to be on the tangent. Okay, so 0.2857, where is that? 0.28, oh here.
16.
It's, right? It's 16 degrees. Okay, so it's about 16 degrees. Is it exactly? No. Let me show. Oh, because I just divided 2/7 on the calculator. And then, okay, so that's about 16 degrees. Oops. So it's about 16 degrees. And of course, angle B has got to be 74, right? If that's 16, right? Those two are complementary to each other, right? It's got to be, so angle B is 74. Is that okay? So how would you write your exact answer though? Because that's not exact answer. How would you, because I told you I want exact answer and approximate. How would you write down the exact answer for angle A? What sort of notation do you need? One person? Two? Discuss with your group. Go ahead. What do you think I'm going to do? So we know that tangent of A is 2/7, right?
Yes.
Remember, whenever you're looking for the actual angle measure, in other words, if you were going backwards, I told you, how do I go to this tangent on the left side? Multiply. You do tangent to the -1 power, which is called tangent inverse. You take tangent inverse from of both sides. Okay, and what do I remember? Like just like x times x to the -1 power is just 1, right? What happens to tangent to the -1 times tangent? They cancel out. You just get a is equal to, that's your exact answer. Tangent of -1 over 2/7. That's it. That's your exact answer. There's your approximation. Is that okay?
Yes.
And actually, if you wanted to know your more accurate value than this, you could punch this in your calculator, and it'll get you a lot better approximation than 16 degrees. Yeah, question?
So for part 1 of this example, would we also have to find the exact answer?
Yes, and the exact answer is just simply tangent A is equal to 2/7 like this.
So wait, what's
Or
the
would we also have to do the approximation?
Oh no,
Wait,
unless they ask you for it.
wait, can you go down again?
Sure. So if you have a calculator, why don't you punch this into your calculator? See what it comes out to. I'll do that. Oh, let me do it too. Here. So what do we need? 2/7, right? 2/7. Okay, we get this, right? We want tangent inverse, click inverse, and then click tangent. It comes out to be 15.95. It's about, so A, 15.95 degrees. What did we say before? Oh, it was 16. Yeah, so it's close enough. But this is more accurate if you want it.
Wait, do we have to do 5.95 or just the top one?
No, just top one. This is fine. But I just did it just to show you. Any question? Yeah. Do you see what to do? Can you do something like this for your homework tonight? Yeah. Have a great day, guys. Thank you.